These notes are going to show you how to solve an equation when you have variables on both sides of the equal sign. You will have to move things from one side to the other, so there will be instances where I describe jumping the wall, and I will show you exactly what that means. The first thing I'm going to give you are steps to solve, and you do have to follow the order of these steps if they are present. The very first thing you must do is to distribute. You will always distribute first in every equation you do, so you get in the habit of doing that very quickly. The second thing you will do, if it is there, is to combine your like terms. And then here is where the variables on both sides come in, and that's at step 3. In order to get the variable from one side to the other, if you move the smallest variable term to one side by adding or subtracting the term, you have then moved that variable to the other side of the equal sign. Once you get past that step, you're just going to solve a simpler equation. Sometimes it's a two-step equation and sometimes it's a one-step equation. Just depends on what you're left with. So we basically just say solve the simpler one. Okay. Now with this type of equation and variables on both sides, there are some special cases that are going to pop up. And these special cases don't happen all the time, but there's a couple of times where you'll see it happen and you need to know what it is called. All right, these special cases occur when all variables cancel out. In other words, you have no letters left in your problem. Right? And the first case is when you have a number that equals itself. So the same numbers that equal each other. Basically, it looks like the reflexive property, but it's not called a reflexive equation. It's called an identity equation. So if your two numbers equal each other, we call it an identity equation, and that's your answer. If the two numbers are different, so the one number does not equal the other number, then we call this a no solution equation. And that is your answer to that one. So you're not going to have x equals a number in these types of cases because there is no more x. You're going to have an identity or a no solution. And I'll show you what those look like through the examples. Right, so the next thing we're going to practice is what the examples of these look like, so you can see how you need to move things from one side to the other. Okay. Make sure you copy it down correctly first, because that does make a difference in what you're trying to calculate. And at this point, this is where that wall comes in very handy, because you can see the left side and the right side and everything you need to do on both sides. You'll notice that you have to distribute on both sides of this wall, so that's the first step that you must do. Negative 3 times 2c is negative 6c. Negative 3 times negative 1 is a positive 3. Go to the other side and distribute over there. 4 times c is 4c. 4 times 5 is positive 20. Okay. You do not need to combine like terms because on each side of the wall there's nothing you can combine. It is now time to move one of your variables to the other side. If you pick the smallest one, in this case it would be negative 6c, we're going to send it over the wall, right, by doing the opposite of subtracting 6c. So we're going to add 6c to both sides. Do line them up underneath their like terms so that you can see how on one side it cancels out, but on the other side you'll still have it. So on the left you still have the number 3. On the right, 4c plus 6c is now going to make 10c, and then bring down the plus 20. Right, you now find yourself back at a normal two-step problem, so you guys should be very comfortable with these by now. Subtract 20 from both sides. You have negative 17 equals 10c. To separate the 10 and the c, you're going to use division, so we divide by 10. Okay. And negative 17 cannot be divided by 10 perfectly, so remember in my class that if it doesn't divide, you don't turn it into a decimal, you leave it as a fraction. This cannot be reduced, so your final answer is negative 17 over 10, and that's how you want to leave it. Okay, so it comes down to making sure you move one of the variable terms to the opposite side by either adding or subtracting it over. All right, the second example, it's more practice of the same stuff. I'm just changing it up and putting different pieces in so that you can see how all the steps fit together. Again, put your wall in. Okay, and the first thing you want to do is also distribute on both sides, and then from there we will have to combine because we have extra stuff. 5 times r is 5r. 5 times 3 is plus 15. Bring down the minus 6. Go to the other side and distribute your 3. 3 times r is 3r. 3 times negative 2 is negative 6. And bring down the minus 9. Now you'll notice on both sides that you've got some combining that you can do. Right? On the left side, we can put positive 15 and minus 6 together and make only one number out of it. So this turns into 5r plus 9. On the right-hand side, we can put the negative 6 and the negative 9 together because those are like terms. So that makes 3r minus 15. Right? So now you're ready to move your smallest variable, and in this case 3r is smaller than 5r. It's a positive 3r, so we're going to subtract 3r from both sides so that the 3r goes away. 5r minus 3r leaves you with 2r. Bring down plus 9, and it equals negative 15. Make sure the negative sign stays with the 15 because they're permanently attached together. Okay, and now you're back to your two-step that we can solve like we normally do. Subtract 9 from both sides. So you have 2r equals negative 24. Divide by 2, and r comes out to be a nice integer of negative 12. No fractions in that one. Okay. I want to show you one that has fractions in it. Everybody's favorite. But remember in class I showed you some tricks about how to get rid of these fractions. Those are going to come in very handy as we keep making our equations get more difficult. Right. This one does not have distributing, so we do not need to start there. You do have variables on both sides of the wall, right? But the first thing you want to do is probably get rid of those fractions, unless you're comfortable using them, and some of you are, right? But most of you are going to like the fact that if you multiply the entire equation by 9, which is the denominator, then you can make this fraction or this equation have no fractions in it at all. So the 9 on the outside takes off the 9 on the bottom. That leaves you with 4u. And then remember, you have to multiply the 9 times the negative 6. 9 times negative 6 makes negative 54. So fraction's gone from the left. Do the same thing on the right. The 9 will cross off the 9 from the bottom of the fraction, and you have 7u. And then don't forget 9 times positive 8 will give it positive 72. Right? And now at this point, you're ready to move your variable term. So we pick the smallest one, which is 4u. It's positive, so in order to move it over the wall, we want to subtract it. Cancel it out. You have negative 54 equals 3u plus 72. You're at your normal two-step, so subtract 72. Okay, and now you've got negative 126 equals 3u. Divide by 3, and you should get the value that u equals negative 42. Okay. And even if you left the fractions in there and used them the way fractions are meant to be used, you're still going to get negative 42. But if fractions are not your favorite or you don't know what to do with them, get rid of them. Okay. Now the last two examples are going to go back to those special cases, and I want to show you what they will look like when you run into them. That way you won't be surprised as to how to answer them or how to deal with them. Right? And they're not as complex as some of the other ones we've seen, but some of them can be. Right? So you look, you see you have variables on both sides. Both of them are 10. So in terms of moving the smaller one, they're both the same. So just pick one. In order to move 10y, you have to subtract 10y. Well, when we subtract 10y, something special happens. They both cancel out, which means you have no y's left. You have negative 2 equals positive 9. That is not a true statement. Negative 2 will never equal positive 9. So this is an example of a no solution equation. And that's your answer, is no solution. I mean, there's nothing else you can write for that. But you do have to show your work to justify why it is no solution. You can't just jump from problem to answer. It doesn't work that way. All right, and then the last one that we will take a look at has a little bit more of our steps in it that we can apply. So the first thing we want to do is distribute. 4 times x is 4x. 4 times 12 is 48. Here's your wall. On the other side, leave the 40. You're going to distribute the 2. So 2 times 4 is going to give you positive 8. 2 times 2x is going to give you positive 4x. You have to combine your like terms next. On the right-hand side is the only side that you do have like terms. So that 40 plus 8 need to go together. So we have 4x plus 48 equals 48 plus 4x. And some of you can see right here what's going to happen, but you do have to continue with the work to support what answer you're thinking about. All right, so we do have to subtract the 4x from both sides to show that they do cancel out and a special case will occur. And now you're left with 48 equals 48, which is a true statement. That will always be true, that 48 does equal 48. So this is what is known as an identity equation. And the reason that it's identity is because no matter what value of x that you plug into this equation, they will all work, right? In a no solution equation, the value of x that you plug in will never work because nothing's going to be true. Okay, so we'll practice with those in class through activities and see if you can handle variables on both sides.